going to find inverses if the inverse is also a function. So that comes into play. We're going to write something down about a horizontal line test. And if your graph doesn't pass the horizontal line test, then you don't have to find an inverse because it won't be a function. So side note, kind of keep that in mind. That's going to come into play. So we're focused on functions only. All right, first thing, real quick notation. This is on the preview assignment. It looks like a -1 exponent, but you just read it F inverse. So you can notate it F inverse of X, inverse notations. You should know, and you really should have come into the room knowing from Algebra 2, but this is just a little refresher in case you don't, that to find inverses you switch X and Y. Whether that be in a table, on a graph, in an equation. Some of you may also write down like switch X and Y and solve for Y so that you remember to do that in an equation. Because you're switching X and Y, X's are all your inputs and they make up your domain. Y's are all of your outputs and they make up your range. When you find an inverse, you switch domain and range. So the domain of the original is the range of the inverse. And the range of the original is the new domain for your inverse. Okay, so you're not only are you switching X and Y, but you're switching their domains and ranges. Okay. And then last thing on here, and I'll move this up so you can see it, just real quick reminder about verifying inverses. If you were asked to verify inverses, you're doing two compositions. Now, I wrote them as f of g of x. You can rewrite that if you want, like it is on your green sheet, f of f inverse of x. So one is the original, one is the inverse. Two functions are inverses if and only if both compositions equal x. So those are some of the basics. These should all be things that seem familiar to us from Algebra 2. Maybe applying domain and range is a little bit different, but that follows with the switching of X and Y. So graphs of inverses, this is what Emily asked about on the 1.9 preview assignment. The graph of F inverse is a reflection of F in the line y equals X. So inverses are always reflections over the line y equals X. I'll do an example. And because it will be helpful for us to think about this visually for one of our examples, I'm going to do the square root function. So I'm going to just do the inverse of its parent graph on a graph. So the parent function would have a point at 0, 0. It would have a point at 1, 1. And then a point at 4, 2. And then it will continue. So there's my square root function. Imagine it went through my actual point, okay? It's hard up here, all right? Okay. And then if I wanted to do the inverse, I just switch the x and y's of all those ordered pairs. So 0, 0 is the same point. 1, 1 is the same point. And then 4, 2 becomes 2, 4. So I go right 2 and up 4. And this is my square root graph, right? Okay. So this is showing us that these two graphs are a reflection in the line y equals x. And you can kind of see over here with 4, 2 and 2, 4. Okay. That they're a reflection over that line. Okay, so if you fold on that line, it maps over to the other side. And the other thing that I want you to be thinking about visually with this is why on that second, I think it was number 3 on the 1.9 assignment, why I had after my quadratic x minus 7 quantity squared plus 3, why I said that x had to be greater than or equal to 3. Because if you say that the inverse is quadratic, you would imagine a full parabola. But if it came from a square root function, you're only going to have half the parabola. So that's something for you to be thinking about visually is, okay, what did my original function look like and what would the inverse look like? I might have to restrict my domain on the inverse so that it matches the picture. Okay, don't want a full U because there's no other points to reflect to get that other side. Okay. All right, and then last set of things before we do examples, we're going to write down the horizontal line test here. Horizontal line test is very similar to the vertical line test. You're going to think about the original function, whatever they're giving you and asking you to find an inverse function for. If you pass a horizontal line through the function, it can only pass one point at a time. So if no horizontal line intersects the graph of f at more than one point, then f has an inverse function. The key word here is the word function. F can still have an inverse, so you can still switch x and y and solve for y. But if it doesn't pass the horizontal line test, then the inverse will not be a function. And we're only interested in inverse functions. So we're going to make sure it passes the horizontal line test. What we're finding are things called one-to-one functions. One-to-one means f is a function. Definition of a function from earlier, first week of school. Every input has at most one output. Every x maps to one y. A one-to-one function says it's true the opposite way as well. Every y only corresponds to one x. So one-to-one functions are functions or relations that pass a vertical line test and a horizontal line test. Okay, next up, examples. Now, in your homework and on the test on Wednesday, you're going to be asked to find an inverse and also state domain and range of the inverse. I'll show you when we're doing our examples that I like to consider the domain and range of the original function to help me make sure I get a correct or an accurate domain and range for my inverse function. So we're going to do the first one on the left, f of x equals 5 minus x over x plus 2. And I would make sure to put this one in my notebook because this is brand new to all my pre-calculus students. You had not done rational functions in Algebra 2. So this is one that you definitely want to practice. Alright, because this is my notes and this is my first example, I'm going to do, on the very first step, I'm just going to rewrite f of x as y. You'll see me on my next examples. I'm going to skip that step. I know f of x is y, so I can replace it with x. Okay, but on this one, I'm going to go ahead and do that, and then start my work for finding an inverse, which is to switch x and y's. So everywhere I see y, write x. Everywhere I see x, write y. Okay, think about, we've switched x and y. Now we want to get y all by itself. What are we going to do first? Multiply by the denominator, y plus 2 on both sides. So like Tristan had done on that number 4, we don't want y in the denominator anymore. So multiply by y plus 2. Some of you may also call this cross multiplying. That's the same thing. So that's fine. Those things cancel out. And then when you multiply this y plus 2 to the other side, what else are you going to do? Go ahead and distribute through the parentheses. Because if you don't distribute, you're just going to go back to what you were before. So we've got to distribute. So we're going to get xy plus 2x equals 5 minus y. This is our wall. This is the place where our Algebra 2 knowledge, we had not done an example, so we didn't really know where to go. But we're going to focus on the idea that we're trying to solve for y. So what's important if you're trying to solve for y? Where do all your y's have to be? On the same side. Doesn't matter which side, on the same side. Abigail said on the right, and I would like to add y only because I like to keep things positive if possible. So I'm going to add y to both sides. So that's going to give me xy plus y. And at the same time, I don't want anything on this side that doesn't have y in it. So the 2x has to move to the other side as well. So I'm going to subtract 2x from both sides. Okay, so that leaves me with 5 minus 2x. Are we okay with our rearrangement there? So now that we got y on one side, what can we do? Before we divide by anything, factor out the y. So we want just one y so that we can eventually have a y equals answer. So I would say at this point, when you get all the y's on one side, and you'll have two y's. Okay, so when you get the two y terms on one side, factor out the y. Okay. So y times the quantity x plus 1 equals 5 minus 2x. And now you can get y all by itself by dividing by x plus 1. So y equals 5 minus 2x over x plus 1. And you could, if you want, write f inverse of x. Questions, concerns, clarifications about what we did? These are the 3 steps that everybody needs to practice, right? So you feel ready to go on Wednesday's test. You know exactly what you're going to do. Move the y's to one side, factor out y, divide. That all works very similar. Now, next up, we've got our new inverse function. Remember that the directions asked also for domain and range. So on these that are rational functions, I'm going to do them like this. First of all, this looks like combinations of functions that we did last Thursday. F divided by G. How do you find the domain if there's division? What's our issue? The denominator can't be 0. So the domain for this new inverse function is everything but negative 1. So then we write that in interval notation. Negative infinity to negative 1 in union with negative 1 to infinity. And make sure in your notes you've got parentheses on all of that. Do not include negative 1. Okay, so domain is pretty easy for a rational function because I just set the denominator equal to 0. Range on a rational function, you do have knowledge from Algebra 2. It involves the horizontal asymptote for the graph, but we haven't covered rational functions yet. We're going to do that in Chapter 2. So I'll give you all those rules in Chapter 2, but I'm not going to give them to you today because that's a lot to know. So we're going to go off of the idea that the domain and range are flipped. So this domain is really the range for the original function, and the domain of the original function will be the range of our new. So we just said the domain of the inverse was everything but negative 1. So that's the range for the original. If we could find the domain for this function, that'll be the range for our inverse. So what's the domain for the original? Everything but negative 2. So we would say negative infinity to negative 2 in union with negative 2 to infinity. And we can just copy that down to the range. So the domain of the original, the x's, are now the range, or the y's, in your inverse. So we would say negative infinity to negative 2 in union with negative 2 to infinity. So that's also something that you probably need to practice on the homework tonight. Anything else? Questions you want to ask about that?
Like on the domain and range, so for the bottom one, for that, yourself, the domain is the denominator and the range is the numerator?
No. The domain for this inverse is whatever, everything but what makes the denominator equal 0, right? Okay. There is a rule about horizontal asymptotes for rational functions, like you have to look at the degree of the numerator and the degree of the denominator and compare them, yada yada yada. But we haven't reviewed those yet together in pre-calculus. So I don't always expect students to know them from Algebra 2. So to find this range right here, we're going to go to the original function and find the domain of that function. Because the domain of the original, the x's, switch and become the y's.
So you're always just looking at the denominator.
Always looking at the denominator for both of those. The denominator of the inverse gives you the domain of the inverse. The denominator of the original gives you the range of the inverse. Okay. Let's do f of x equals cube root 7 plus x. I sort of spaced here on the first one because I'm always so excited to do that rational function that I forgot to do our horizontal line test. It works. Okay. Does anybody remember the shape of the cube root function? It's not on your 8 basics. The cubic function is. What's the cube root function look like? Very similar. This was our cubic function. Yeah, it's like on its side. Okay, so I'm going to sketch what the cube root function looks like. This is a parent graph for the cube root function. Something like that. Do you remember that from Algebra 2? When you did square roots and cube roots? Okay. This one would be shifted left 7 because it's got x plus 7 underneath. So just imagine it shifted left 7. Would that pass a horizontal line test? Yeah, so it means there is an inverse function. So let's find it. So I'm going to start with step 1. Switch x and y. X equals the cube root of 7 plus y. What steps will you take to get y all by itself? Cube both sides. We got to get rid of this cube root. So that's x cubed equals 7 plus y. And then subtract 7. So y equals x cubed minus 7. And if you want, you can label that f inverse of x, or you can call it just y. Either one is acceptable. And then we have to do domain and range. Look at the cube root function, the parent graph. What's the domain and range of the cube root function? Domain? All real numbers. Range? All real numbers. It's always going left and right. One side's always going up, one side's always going down. It's all real numbers. And think about the cubic function. The same is always true. Okay, so domain would be all real numbers, and range will be all real numbers. Sorry, I ran out of room right there. Emily?
Do you not want to have a negative under a radical?
I don't have a negative under a radical.
Well, but if you have all real numbers, can't you plug in something like 7 plus negative?
Oh, but a cube root, I can take a cube root of -8. It's -2. It's if they're even numbers, you're not allowed to have negatives. So if it's an odd root, your domain would be all real numbers, again. And you can tell that in the graph because this one is pointing towards negative infinity on the left, and this side is going towards positive infinity on the right. So it's going everywhere. Okay, let's do another one. This one's like number 3 on the 1.9 preview assignment, the square root of x plus 1. Okay, I'm going to sketch my graph using my transformations. So that's a square root graph, and it's moved left 1. Okay, so I can imagine what that graph looks like. I'm going to go left 1, plot a point, square root, looks something like that. Does it pass the horizontal line test? Yes, it does. Inverse. Switch x and y. X equals the square root of y plus 1. It's very similar to our cubic function. Square both sides, subtract 1. So we'll get x squared equals y plus 1. Y equals x squared minus 1. When I do domain and range, this is one where I should really look back up at the original. So it is important to consider the original. What's the domain for this square root graph? What's the first x that works? -1. And then it goes to positive infinity. What's the range of this graph? What's the first y that works? 0. So remember, the domain and the range of the original will be flip-flopped in your inverse. So our domain is now 0 to infinity, and our range is -1 to infinity. And so this is one problem where in my inverse function, I should add a restriction there. Because if I just gave this function to Isabel and said this is the inverse, she would graph a full parabola that shifted down 1. And I really want only Isabel to only graph that one side of the parabola that is its reflection. So then I look to the domain. Since the domain starts at 0, then I would say for all x's greater than or equal to 0. So it's a little thing, but it's important. You guys could know to keep an eye out for that anytime you take a square root and you turn it into a quadratic, you're going to have to restrict your domain. Questions about that, why I did that? Okay, last one. F of x equals the quantity x plus 1 squared. What shape is that? Parabola, shifted left 1. Does that pass your horizontal line test? No. Here's my parabola. Horizontal line. Does not pass. No inverse function. Done. Okay. Don't have to do anything. I only want you to find inverse function. So if it doesn't have an inverse function, don't find it. Now, the textbook could give you an alternate question. It could say, find the inverse for f of x equals the quantity x plus 1 quantity squared, such that x is, let's see, greater than or equal to -1. Okay? And then it would be highlighting only the right side of that parabola, and then you could find the inverse, which will be a square root with a domain that's restricted. So if it has the restriction, you can do the work. If it doesn't, then you just say no inverse function. All right, here's your homework assignment for tonight. And it's on your gold sheet, last homework assignment for the chapter. Reminder that your test is this Wednesday. You need to make sure that you're prepared because you have